So guys, here you can see one more video came on the LeetCode channel, and today's video we are tackling our question number 530 by the name of minimum absolute difference in PST. Okay, and now this medium one question means easy one question which we are solving in today's video, and this question is totally on about tree, depth first search, breadth first search, and binary search tree and binary tree. Okay, BST means binary search tree. Okay, now in today's video we are covering this 530 question, and please don't forget to like, share, subscribe, and don't forget to all this notification bell also, so you know some of these type of videos on this channel of the Rayyan. And one more thing, I wanna tell you that we are very near to 5,000 subscribers, so please complete it. Then I will be officially launch a one course for you, okay, which you will be very enjoy. Okay, so now let's move to computer screen and let's solve the 530 question by minimum absolute difference in BST means binary search tree. So let's move to computer screen and let's do a coding with laughing. Guys, let's start to solve a 530 question by the name of minimum absolute difference in BST. BST means binary search tree. Okay, so let's start to solve it. So first of all, we understand the question. What is the question is trying to say us? Then we'll be start to solve it in the LeetCode camp. Okay, now let's start. Now it has given me a one root of a binary search tree in the short form if you call this is our BST, and we want to return the minimum absolute difference between the values of any two different nodes in a tree. So there are totally two cases it has been given me. If you see here, first case and second case. So now first of all, it has been also given me a two diagram also for binary search tree mean of BST. So let's understand these two diagram. So now if you see this first diagram, this diagram, if you see it is our starting with 4. Let me give him the red color. Here you can see here he wrote it down 4, and then it is coming from 2, then it is going on to the 6, and then it is going to the 2, it is going 2 from 1 and 2 from 3 also. And here he wrote it down input, here he wrote binary tree in which he wrote down 4 2 6 1 3. Why? Because it is going like 4 2 6 1 3, and the output is coming 1 here. Okay, why? Because it is giving like I've told you here, we want to return the we want to return the minimum absolute difference between the values of any two different nodes in a tree. Okay, so that's why it is giving me the output 1, because there's one minimum absolute difference between the values of any two different nodes in a tree. So that's why here you can see it. So if you see the case 2, here he did a case 2 in which he wrote down 1 here, and then this second diagram, then 0, then 48, then 12, and then if you see here he wrote down 49. And here in the root integer area, you can say in the root by tree, here he wrote it binary search tree, here he wrote it down 1 0 48, and then null, then 12 and 49. The output I'm coming 1. Why? Because the 1 is in the top, and because we wanted in the minimum absolute difference between the values of any two different nodes in a tree. So that's why. Okay, so these are the constraints which used to solve this question, and it has been given me this question is the same as 783, means that this one question it has been given me same like this question. Okay, here you can see, let me open it. Here you can see it. It is the same question of like this. Okay, like this question 530 question. It is the same question. Okay, now let's start to solve this question. Now let me tell you how to solve this question, and we are solving our question number. Let me tell you what is our question. This is our question number 530, minimum absolute difference in BST. And please, if you do not understand the question, so please rewind my video and see this question. Please read the question one more time. Now total 8,63,000 people had submitted, and only 5,07,000 has been accepted. And this question is the topic is about tree, depth first search, breadth first search, bias tree, and binary tree. And now we are solving this question in the Python 3. So let's start to solve this question, and these codes are very low. I mean, there is not many codes. Okay, so first of all, here we define a one comment of definition of a binary tree node. Then here we define a class tree node, and we are defining this all the thing in the comment self bl equals to 0, left equals to none, right equals to none, back enter, sorry, space, self dot val equals to val, self dot left self dot right equals to right, and please define it here comment perfect, and then give the backspace here. Perfect. Now enter. Define here class of a solution. Now there's a rule of a LeetCode that whenever you start to solve any question, so first of all you define a class of a solution. If you did not define a class of a solution, so otherwise it will be giving you an error. Okay, now define a def keyword in which you define get minimum difference, because this is our topic, self comma root optional tree node int. Perfect. Now let's see the running code. Now we write it over all the code. So study the running code has been correct or not. So when I run this code, it has been running, and now it has been giving me an error. And which line has been giving me an error? So let's see. In the import sys, it is giving me an error. Indented block. Okay, it is giving me one error. So let's see. That okay, define your difference. We by the mistake I define here different, so that's why it is giving you error. Now I hope it not give you any error. Now let's run. Now it is giving me still it is giving me an error. So let's see what is the error. Okay, so now I think so our different error has been gone, but it is giving me some different error. Now here we write definition of a binary tree node. Then here we define a class tree node that def init self comma val equal to 0, left equals to none. Okay, none and should be in capital. And then when we do this all the thing, so that here we define self comma val equals to val left and right. Perfect. Now define here class for solution. Enter. Perfect. Def get minimum difference, then remove it, self comma root optional tree node, then minor greater than int. Perfect. There's one definition of a binary tree node. Okay, you do not think that is a code. Okay, please this take it as a definition of a binary tree node. Okay, now let's remove it. Let's remove this all the thing. Now do like this, and now let's see. Okay, indented block after a function definition on the line 66. There is not any line 66. Import sys. Okay, it is saying me import sys. So let's see. Let's import it. Now let's see. Okay, now our that error has been gone, but it is giving me some different error. Okay, let's do this in the comment. And now import sys. Now let's run. Now it is giving me the output null. So let's see what is another error. Now you what want to do is remove it from the comment. Okay, remove these all the thing from the comment. Now let's do this. Remove. Now let's see the running code now. Now it has been accepted. Our case 1 has been also accepted and case 2 has been also accepted. So now our last step is to submit this, and let's see the submission code. So when I submit this code, the submission is also be correct and I beats 83.80% people. And let's paste this solution, easy solution in Python 3 beats 88% and visit code with Rayyan, sorry, not Rayyan, Rayyan for explanation and concept. And then I paste the solution. So thank you. So in today's video, we beat our question number 530 by the name of minimum absolute difference in bind search tree. So I hope you enjoy this video. If you enjoy, so like, share, subscribe, and don't forget to all the notification bell also, so you know some of these type of videos on this channel. And this is my profile by the name of Rayyan. So if you want to view my profile, so you can also go and view my profile. But this is my profile by the name of Rayyan. So now let's meet you in the next video of the solving. So now for today, goodbye.